Welcome guys. So in this video, I want to do a simple computation. So one computation in one idea in the Lie group theory is that if G is a compact Lie group, then one can show the pi3G were isomorphic to Z. Okay. Before I start, please subscribe to my channel. Okay. So this can be done by computing. This can be done by using some big theorem like the compact Lie group, and go to the algebra and do other things, right? But in this video, I just want to prove some special case. So I will prove the classical group case that G is SON or SUN or SPN. Okay. So to prove it, it's not so difficult. We're just using the vibration sequence and take the homotopic. Okay, so this is just some simple results. Okay, so SON plus 1, right? So SON is special orthogonal group. It has a simple vibration. I think it's this guy. Also for SUN, we also have the similar vibration, 2n plus 1. I think this is 4n plus 3. And the SPN plus 1 symplectic group, SPN. Okay, so our goal is to show that so let's write down the goal. So our goal is to show pi3 SON and equals to pi3 SUN equal to pi3 SPN, and then it should be n, right? So this should be, I think it's n greater or equal to 5. I think it's correct, right? Because and this is n greater or equal to 2, and this is n greater or equal to 1. Okay. I think 3 is okay, but yeah. Okay, so 3. Yeah. Okay, I think so. Okay, so yeah, so this is the proof that we want to establish. Okay. So okay, so let's quickly see the key, right? So the key idea is that you have a fiber bundle from FE to B, FEB, the base space, and then you will have the pi n F, pi n E, pi n B, and then you keep going until go to pi n F, pi n minus 1E, and then pi n minus 1B, and you keep going. Then until you get the final one. So I think it's pi 1B, and then keep going. Okay, so let's using this vibration sequence at the first guy. So let's quickly see. So we have this, and then we can take the exact sequence. So let's go to pi3 SON, well, the same as the pi3 SON plus 1, pi3 SN plus 1. We see this region, so pi4 SN plus 1. Right, so from this that we know that the pi k SN is 0 if k is from 1 to n minus 1, right? So basically, if k is so large enough, then pi k will be 0. So let's say, so in order to be these two to be 0, right? So we hope that what? We hope n plus 1 should larger than n plus 1 can larger than the, let's say. So if n is larger than 3, greater than 3, right? Then this will be s. Just that n equals to 4, right? This will be s5, and this will be s5, right? So n larger than 3, then this thing will be 0, right? So that means these two are isomorphic. Okay, so from this vibration sequence, we can show pi3 SON we're isomorphic to pi3 SON plus 1. So right, so that means if you keep going down, right, until you get pi3 SO4. Maybe that's maybe pi3 SO5. So SO5 is the key. Okay. Okay, so that means we prove that pi3 SO5 is isomorphic to pi3 SO6 and the pi3 SO7, and then we keep going. Okay. So the idea is that we don't know how to compute it, right? But we can just write down. Okay. Then how about this, right? And then we do the same thing, and we will get the same exact sequence, just pi3 sun isomorphic to pi3 sun plus 1, right? And this guy is 2n plus 1, right? So that the idea is that 2n plus 1 should greater than 4. So I think n is greater than so this is 3, right? So n is greater than this one. So n is 2 is enough, right? So we can prove that the pi3 su3 is isomorphic to pi3 su2, and that is also isomorphic to pi3 su, let's say 4, and then keep going. So it keep increasing, right? And then for a final guy that I don't have to write it, but you can check that it's SP. You can also starting from SP1 and SP2, and keep going. Okay, so now the idea is that how do we compute, right? So that means we can go to the lower Lie group exception. So Lie group when n is small, then these three kind of Lie group can have some, their Lie algebra can have some overlap, right? So we know that the SU2, right, as a topological manifold is S3, right? So from Hurwitz theorem, we know that this guy. So this is our induction point, right? So this proves that this is Z, right? These are all Z, right? But we also know that this SO6 is isomorphic to SU4 quotient Z2. So SO6 has the same Lie group as has the same Lie algebra as SU4. But as a Lie group, SO4 is SU4 mod Z2. So basically, you can view SU4 as the spin 6. So it's isomorphic to spin 6 is a double cover of SO, let's say 6. So that means what? That means this is discrete part, right? So that means they have the same homotopy. So that's if you take pi3, that means it's exactly as pi3 SU4. pi3 SU4, right? So this guy will be Z or Z. Okay, and finally, we still need one exceptional case to connect symplectic group, and you guys can Google online. But yeah, this is the result. Is that I think SP1 is SO5, I think, and the quotient Z2. Let me. Oh, wait. Oh, sorry. Sorry. Okay, what I'm writing wrong. Sorry. So SO5 is the same as SP2 quotient Z2. Sorry about it. I'm stupid. Okay. So from here we know that Z2 is a discrete part. So pi3 SO5 will be the same as pi3 SP2. So it's on all Z. Okay, and I think one can show that the special case for the SP1. I think so one can show the SP1 for special case. I think SP1 is something SU2 or something. So I forgot. But so the idea is that if you're using a vibration sequence, then once you choose this, once you find this SU2, right, then everything can be connected. So this is the idea that how we can prove in some special case this is correct. Okay. And the other exceptional Lie group can also prove by this way. So basically, you can connect G2 and F4 to this classical Lie group, and then write down the exact sequence, and then you can prove they are correct. Okay, and I will. So that's it. So this video just try to demonstrate a simple class calculation of the fiber bundle. Okay, I will see you guys in the next video. Be sure to subscribe to my channel. Thanks.